When you stand outside on a clear evening, the universe presents a very specific image. You see a quiet, static tapestry of twinkling lights. The stars stay in their places, the planets follow predictable orbits, and the entire night sky projects a comforting sense of order. But that tranquility is an illusion, a trick played on us by extreme distance. Space is actually a machine of unimaginable violence. As our observation technology improves, we are learning that human intuition is entirely useless out there. Our earthly concepts of weather, distance, and safety do not apply to the deep cosmos. To understand the true nature of what is happening above our heads, we have to look past the beautiful, glowing dust clouds. We need to examine the terrifying, hostile extremes hiding in plain sight. Take Pluto, for example. In the images we usually see, it looks almost inviting. A quiet, frozen dwarf planet marked by a bright, heart-shaped formation stamped onto its surface. The reality is that Pluto is an abyss of absence. There is no ambient heat, there is no breathable oxygen. If you attempted to travel out there, the journey itself would slowly dismantle your biology over several years, degrading your bones, muscles, and vision long before you ever arrived. The sheer scale of the distance makes reaching it incredibly difficult. In 2015, the New Horizons probe finally reached Pluto. It was one of the fastest objects ever launched by humanity, yet it took nearly a decade just to do a brief flyby without stopping. This chart shows the core physics problem that makes a manned mission nearly impossible. To slow a spacecraft down from those massive speeds, you have to fire your thrusters in reverse. That requires carrying a massive amount of extra fuel, which you can see represented by this fuel weight bar. But the math gets much worse. If the ship adds a new fuel tank to slow down, that fuel has its own mass. To push that extra mass across the solar system, you have to add even more fuel at launch, causing the required weight to multiply exponentially. This is the rocket equation, and it creates a compounding mathematical nightmare. Pluto does not actively try to kill you with crushing gravity or violent storms. It destroys you passively, letting the inescapable laws of physics and the freezing emptiness of space do the work. Moving outside our solar system, we find targets that look deceptively familiar. Located 64 light-years away is the exoplanet HD 189733b. Through a telescope, it appears as a beautiful sphere of deep blue, looking very much like Earth or Neptune. You might expect that color to come from oceans of water. Instead, it comes from a thick, choking atmosphere saturated with silicate particles. We can see why this atmosphere is so volatile in this orbital diagram. The planet is caught in tidal locking. Because it orbits incredibly close to its star, one face is permanently turned toward the heat, glowing at over 1,000 degrees Celsius, while the other is trapped in freezing darkness. Those arrows represent the massive temperature differentials dragging heat across the surface. Those forces generate supersonic winds, blowing at thousands of kilometers per hour. The intense heat causes the atmospheric silicates to condense, meaning that on this blue planet, it rains molten glass, blowing completely sideways at blinding speeds. Sometimes the illusion is built on sheer scale. The pillars of creation in the Eagle Nebula are light-years tall. Because they are so massive, we have historically viewed them as static, eternal monuments of cosmic dust, hanging silently in the dark. We couldn't see what was happening inside those thick clouds of gas until a new generation of infrared observatories gave us the ability to peer directly through the dust. Inside, there is a violent, chaotic war zone. The gravity inside the pillars is forcing gas and dust to collapse in on itself, sparking the birth of incredibly hot, massive new stars. This diagram illustrates exactly what those newborn stars do to their surroundings. The star in the center emits intense ultraviolet radiation. When those waves strike the dense clouds, they scorch the material, causing the gas to literally boil away into space. This is photoevaporation. The very act of stellar creation is a destructive process. The intense energy of the newborn stars is actively eroding the pillars, erasing the exact environment that birthed them in the first place. If we zoom out even further, we find objects that operate at the extreme limits of energy and scale. Quasars look like faint, twinkling stars, but they are actually supermassive black holes radiating the energy of trillions of suns. These quasars can group together into structures spanning billions of light-years across. The existence of structures that large challenges the cosmological principle. This is the foundational assumption that, at a large enough scale, matter in the universe is evenly distributed and homogeneous. You can see the scale of the conflict on this grid map of the universe. That dashed circle represents the theoretical limit of how large a cosmic structure should be based on our current models. But these quasar clusters stretch vastly beyond that boundary. This gap suggests that the universe may be far more complex and less uniform than our current laws of cosmology are prepared to handle. The universe is not explicitly malicious. It simply operates on scales of energy, time, and distance that are completely indifferent to human biology. Every time we build a larger observatory and point a new lens at the sky, we uncover evidence that complicates our image of a safe, orderly environment. Realizing that these apocalyptic worlds and reality-breaking extremes exist makes our own existence on Earth feel incredibly fragile. Paradoxically, understanding this terrifying dark side is what gives our quest for space exploration its meaning. We are finally brave enough to look at the hostile cosmos with open eyes.